Welcome back. In this video, what we're going to do is we're going to find the volume of solid shapes that are formed by different cross sections. Generally, our cross sections are like squares, semicircles, equilateral triangles, maybe some rectangles, that kind of stuff. What you're going to do is you're going to have a region in the XY plane, and that's going to form a boundary of one of the sides of your different shapes that you're looking at. If it's perpendicular to the x-axis, so it's perpendicular to the x-axis, then we find the area of that shape in terms of x. The a and b values, the limits have to be x values. If it's perpendicular to the y-axis, then we find it in terms of y, a of y. General rules that you're going to follow for these problems is you're going to sketch the two-dimensional shape in the xy plane. Identify which variable you're going to use. If you're using x-axis, x is your variable of integration. Perpendicular to y-axis, y is going to be your variable of integration. Find a formula that you're going to use to find the area of a particular shape. Obviously, you know squares and rectangles and semicircles. The one you might not know is the equilateral triangle. It's going to be s squared times the square root of 3 over 4 if you know the side of an equilateral triangle. Find your limits of integration. Make sure those are x values if you're integrating in terms of x, or y values if you're integrating in terms of y, and then integrate to find the volume. In my first example, what I'm doing is I'm taking this region that's bound by x squared plus y squared equals 4. That's this circle with a center at 0, 0 and a radius of 2. And I'm going to make all my cross sections perpendicular to the x-axis are going to be squares. So I want to add up a bunch of squares. So if I find the area of these different squares as I get larger and larger and then smaller and smaller, I'm going to get this kind of odd solid shape, and I want to find the volume of that odd solid shape. What ends up happening is I need to find the length of one of the sides of the square. So if I'm perpendicular to the x-axis, that's what it looks like. This is going to be the side of my square, that whole side. Well, I need to solve this equation for y. So I need to write this part is going to be y equals the positive square root of 4 minus x squared. This side is going to be y equals the negative square root of 4 minus x squared. So if I look at the side of my square, it's going to be a positive square root of 4 minus x squared minus the negative square root of 4 minus x squared, or just 2 times the square root of 4 minus x squared. So now when I go to set up my integral, it's going to be for the size of the square, it's going to be the integral from negative 2 to 2. Those are x values over here and over here. That's going to be the side of my square, which is going to be 2 times the square root of 4 minus x squared. Squared, because it's a square, that's what we're trying to find, dx. Staying on that same region, basically the same idea, but now I just changed my cross sections to semicircles. So I have this kind of dome-shaped type thing. And so the area of a semicircle is 1/2 of pi r squared. In this particular case, the 1/2 pi can come out front of my integral. The limits of integration are going to be the same. But now, when I look at this, in this problem, I got to be careful because I don't need that whole side. I just need this radius. I just need that part of it. That's all I need. This is the radius I'm looking at. This is the square root of 4 minus x squared. So like in the last example, I needed that whole side, but this time I do not. I only need the radius. So it's going to be pi over 2 times the integral from negative 2 to 2, and it's going to be the square root of 4 minus x squared dx. My last one, perpendicular to the x-axis, is going to be equilateral triangles. I think it's interesting to see what this looks like. Okay, it's the same shape in terms of the xy plane. This particular case, I'm going to need this whole distance, and that represents one of the sides of the equilateral triangle. So again, just like my first example, this is going to be 2 times the square root of 4 minus x squared. And then I choose the formula for an equilateral triangle, which has that the area is the square root of 3 over 4 times s squared. So that square root of 3 over 4 can come out in front of the integral from negative 2 to 2, and it's going to be 2 square root of 4 minus x squared dx. The only little trick that they throw in there every once in a while is they'll give you something like this that's perpendicular to the y-axis. When it's perpendicular to the y-axis, then my cross sections are going to go this way across the page, and y has to be my variable of integration. So I have, first of all, y equals 1 minus x squared. I need to solve that for x. So x squared equals 1 minus y, and then when I take the square root, x can be plus or minus the square root of 1 minus y. That's minus y. So this is positive square root of 1 minus y. This is negative square root of 1 minus y. So now my distance all the way across is going to be 2 times the square root of 1 minus y. And in this case, I'm doing squares again. When I do squares, obviously the area is just s squared. So when I do set up my integral, okay, now it has to be y values. So it's going to be 0 up to 1, and it's going to be 2 times the square root of 1 minus y, quantity squared, dy. All right, we'll work a couple of more examples of this in class. Good luck. They're not too bad. You got to memorize a couple of formulas, but they're really not too bad. See you soon.